Alright, so today we're going to talk about what it means for two triangles to be congruent. Now, two triangles are congruent if and only if the corresponding parts are congruent. So what that means is, since each triangle has 3 sides and 3 angles, there will be 3 pairs of sides congruent, 3 pairs of angles congruent, but they have to be in corresponding parts, meaning they're in the same order in their triangles. They just can't be any mismatched order they want. It has to be in a certain particular order. So for example, if we are told the triangle ABC is congruent to triangle DEF, then that means A and D are both equal, B and E are both equal, and then C and F. And the reason why we have those 3 angle pairs picked out like that is because if we're going to take a look at this statement. A and D are both the first letters. They're both equal. B and E are the second letters. They're equal. And then C and F are the last letters. They're equal. And then for the sides, AB is congruent to DE. BC is congruent to EF. And then AC is congruent to DF. The reason why those 3 sides are, AB are the first 2 letters, so are DE, so AB and DE match up. BC and EF are the last 2 letters, so those 2 match up. Then AC and then DF are both the first and last letters. That's why they match. And notice they're across from they're in the same spots. The 1 tick mark is across from 3 arcs, 1 tick mark across from 3 arcs, double tick mark across from a single arc, double tick mark across from a single arc, and then triple tick mark across from the double arcs. Triple tick mark, double arcs. They're in the same spots, therefore these triangles are congruent. If these are all the corresponding parts, it would be incorrect to say this: triangle ACB congruent to triangle DEF. Because we need B and E to match up, and then B and E, third letter, second letter, they don't match. I could say instead, triangle CAB is congruent to triangle FDE. This would still be correct because C matches with F, A with D, B with E, so it still matches correctly. So the names themselves are important, but you can rearrange this in a bunch of different orders for you to name the triangles. So we're told the triangle YZX is congruent to triangle LNM. We want to know which angles and which sides have to be congruent. Well, Y and L are the first letters, so they must match up. Z and N are the second letters, so they need to match up. And then X and M are the last letters, so they need to match up. So again, we would say angle Y congruent to angle L, angle Z congruent to angle N, and angle X congruent to angle M. And as for the sides, well, YZ, first 2 letters, LN, first 2 letters. They're both also across from your triple arcs. ZX is the last 2 letters, so is NM. Notice they're both across from the single arc. And then YX, first and last letters, LM, first and last letters. And they're both across from the double arcs. So we would say YZ is congruent to LN, ZX is congruent to NM, and YX is congruent to LM. Those would be your congruent statements based off this right here. Whenever you want to name them, if you had to go backwards, if you're given the angles and sides, you're going to name the 2 triangles. Name them based off the angles. It's easier to match them. Just put the 1 triangle anywhere you want, and then just match the congruent angles based off that. So for this one, we're told triangle ABC is congruent to triangle FDE. We want to solve for X and Y. So let's give AB a single tick mark and AC a double tick mark, because those are our 2 sides that we know. We don't care about BC because it's irrelevant. It has no measurements. AB is the first 2 letters, so is FD. So that's how we'll solve for X. 8x minus 3 equals 14. So we would add 3 to both sides. 8x equals 17. And then divide by 8. So you either have 17/8 for X or 2.125, the decimal. And then the Y is AC, that's our first and last. So first and last is FE, and yeah, we can solve. So absolute value of 3y minus 7 equals 18. Had for some reason the double tick marks gone to DE, there is no side measurement there, so we would not be able to solve for y in that particular case. So don't assume they will be set up like this. It may be possible that one can't be solved for. Now, if it's absolute value, you need to set up two equations. The first equation is exactly how it appears. 3y minus 7 equals 18. The second equation is 3y minus 7, inside never changes, but now equals negative 18. And normally you cannot have a negative side length, but because we're doing absolute value, the absolute value of negative 18 is still positive 18, so it still works out. So when we add 7 to the first equation, you'll get 3y equals 25. When you divide by 3, you'll have 25 thirds, or 8.3 repeated. The second equation, when you add 7, you'll have 3y equals negative 11. So when you divide by 3, y will either equal negative 11 thirds or negative 3.6 repeated. So you need to remember you're going to have two answers for your absolute value equation, so don't forget that concept. Alright, so once you use what we just kind of talked about, now we're going to apply it to angles. Match up each congruent angle based off the statement, triangle GHI, you're triangle JKL, and then solve for the missing variable x and z. So pause the video while you work that out. Alright, so this is what you should have done to solve for z and x. We'll start with z first, because that one's relatively easy. Z is angle K, and since it's the middle letter, it matches with angle H, which is 134. So we would say 14z minus 15 equals 134. We add 15 to both sides. That's why 14z equals 149. Then we divide by 14, which you can either leave as the fraction 149 over 14, or the decimal is 10.643. There's z. Now x is a little bit more interesting. Angle I, the third letter, is equal to angle L. But we originally did not have a number here. Notice this 25 did not appear originally. I wrote it in. So how do we find it? Well, angle J is 21. K and H are both the same, so that should be 134. Let's fill that part in. There's 134. And all three angles have to add to 180. So we can say 134 plus 21 plus angle L equals 180. And that's how we got angle L to be 25. Once we know L, we can say 8x plus 6 equals 25. Subtract 6, divide by 8. That's why x is 19 over 8, or 2.375. So the key is, do not assume that, again, angles have to equal the ones I gave you. You need to pay attention to which ones should be the same. I and L are the same, not I and J. Alright, so that's how you use your congruent triangles. Now, the rest of this is going to talk about triangle congruence. We don't need all three sides and all three angles congruent to prove the two triangles are the same. We have 5 different congruence theorems that we're going to use to prove triangles congruent when we deal with the next couple weeks. So, side, side, side. SSS says if all three sides of two triangles are congruent, then the two triangles themselves are equal. So if I mark the triangles like this, I have all three sides equal. So now I need to match up the correct sides to have my congruent statements. So triangle ABC is congruent to triangle, well, side A is opposite your triple tick mark. So is angle F, so F would go first. B is opposite the double tick mark, so is D, so D would go next, and that leaves E. And then congruent by side, side, side. So that's our first triangle congruence method. If I can prove all three sides of the two triangles in question are the same, my two triangles will be congruent. Second one is side angle side. This is where if I can prove two sides congruent, like these two right here, and then the angle in between them. Notice G is in between these two sides. So is K. If I can prove this to be true, two sides equal, angle in between, then the triangle is congruent by side, angle, side. So if we name them, so we'll start with G, H, I. So G is my single arc for angle, so it matches with K. K goes first. H is opposite the double tick mark, so is J, so that goes next, leaving L as my last one. And they're congruent by side, angle, side. My third congruence is angle, side, angle. So this is where we have two angles congruent in my triangle. and the side in between them. So we have angle M and O congruent. MO is in between those two. That's why this angle, side, angle. So let's use the same concept. Here's my two angles, Q and R. Side in between them, QR. Angle, side, angle. So to name this, we would name it as triangle MNO. First is congruent to triangle. Well, M is the single arc, so is Q. So Q would go next. N is opposite your single tick mark, so is P. So that goes next, leaving R as your last piece. And again, R and O match up, so it's okay. The fourth triangle congruence is angle, angle, side. So as long as you have two angles congruent, it doesn't matter. The third side can either be in between them or outside them, as long as they're in the same spots. Now, this is a little tricky, so let's be careful. So it's not in between them, so let's put it here. Notice our side is opposite the single arc. My congruent side for this one, if I put my single arc here, my double arc here, has to be opposite the single arc in order to be in the corresponding spots. Had to put my arc over here, it would not be angle, angle, side, because this side does not match up with this one. Opposite single arc, we're okay. So if I name this triangle STU, let's congruent to triangle. Well, S is your double arc, so is X. T is your single arc, so is V. And then W is your last one. W is opposites, matches with U, because notice the U is not opposite any tick mark for sides, or matching with any angles. That's why it's that way. And that's by angle, angle, side. Now, your last congruence theorem is only with right triangles, it's a hypotenuse leg. So we need to have the hypotenuses for the two triangles congruent. Hypotenuse is always opposite your right angle. And one of the legs. It doesn't matter which one, but one pair of legs. If that is true, then your two triangles will be congruent. So if I name these two, triangle AYZ is congruent to triangle A is your right angle, so is D. Y is opposite your double tick mark, so is C. So that leaves B to match up. That's by HL, hypotenuse leg. So we're going to use these 5 congruence theorems over the next week or so to prove why two triangles are congruent. So our job is, we're not going to be given the sides and angles all congruent. We need to show that they're congruent in some way. So stuff like sides, we'll need reflexive sides, meaning they share the exact same side. Bisectors, splitting sides in half, midpoints, base angles, stuff like that to prove why sides are equal, we'll need those. As for angles, we're going to need stuff like vertical angles to prove angles are equal, linear parallel lines to talk about alternate interior, corresponding, alternate exterior, stuff like that. We will need, again, base angles, again, two angles being equal because of an isosceles triangle. We're going to need anything along those lines to help us prove why two triangles are equal based off angles and sides. So that's what's coming next. So I'll see you next time.